quick tutorial on how to set up a microcontroller project for Xilinx Fpga using Vivado. We're using Xilinx Artix7 on a Digilent board of CModA7 35T, and we are using Vivado version 2019. Okay, go to File, Project, New. Okay, next. So we'll call it CModA7 base 4. Next, next, next. Over here, you should have downloaded the board files for Digilent boards. So go to Boards. You should see Digilent here. And scroll down to CModA7 35T. That's our board. Next. That's all. Finish. Takes a moment. Okay, on the left side, go to Create Block Design. That's all right. Okay. Okay. On here on the right side, you have a empty space for the block design. Here, slightly in the middle, you have sources. Design doesn't matter, signals doesn't matter. Go to board, the tab of board. Now, first of all, hit right click on the block design screen, add IP, and type Microblaze. All right, so Microblaze is here. We got it. And it will bring some components from the board. So again, it's the board tab. And we have system clock. That's good. All right, cell RAM. Good. KSP flash, skip it. LEDs, 2 LEDs. Yes, we take it. The push buttons we add afterwards. RGB LED, yes, we take it. Connector JA, not this time. Reset button, yes. And very important, USB UART. Yes, we take it. All right, on the right side in the block design diagram, you should see all the elements, including Microblaze and everything else. On the blue screen, you will see connection automation. Let's try it. Okay, what's here? So this is the megahertz. Yeah, let's go for it. Run block automation. Yes. Now, so options, preset none, and this is the local memory for the Microblaze controller. We want it for 64K, and the reason we need it because we need our software program to have a little bit more space. We'll get to it later. So that's the only change you do here. And okay, this will take a moment. Run connection automation again. Yes, again. All right, so what's here? This GPIO, UART, all. We automated all. Yes. And all right, the green strip run automation disappeared. Right click on the block diagram and go to regenerate layout. Okay, this will make it a little bit more in order. Now we can add the button. So again to the board tab, push buttons, and we need to make a modification here. To put push buttons, we won't just use one button. If we don't use one, if we use two, there might be a conflict with the reset button. So let's use just one. All right, and this run connection automation should pop up again. We use it again. Yes. All right, right click again. Regenerate layout. We got it. Now, when you hold Control and use the scroll on the mouse, you can zoom in, zoom out. So let's check the elements one by one. Clock wizard. Just right click on the module. Output clocks. Let's make sure that we have just clock out 1 selected, 100 megahertz frequency. That is correct. Everything else should be fine. We check the memory. It's somewhere here. Port A, we have 8. Port B, we have 8. Maybe that's fine. Okay. So xgpio1, let's go to gpio2 first. We should be collecting the GPIO to LEDs, the two LEDs on the board and the RGB LED. Let's see how it works. So here is the connection, that's fine. GPIO1, the push button is connected, the custom is not connected, the second bank is not connected, that is good. If you want to increase the memory for the instruction set in the Microblaze microcontroller, go to the tab of Address Editor, and over here UART Microblaze 64K is set up here. Let's assume that this is correct. Let's go back to the diagram. There is one more thing we need to do. It is the UART light. We modify the settings. So IP configuration, and over here the baud rate we change to 115/200 using the clock of 100 megahertz. We can only go up to certain speed. You see that the maximum here is 230,000. If you want to go over that to, let's say, 400,000 baud, we need to increase the clock to 200 megahertz. Right now, let's use just 115/200, and OK. Right click, regenerate layout. Right click again, validate design. Validation successful. If you follow the steps correctly, there should be no errors. Otherwise, there might be some errors displayed. Go to the Sources tab. Click the design. Right-click. Create HDL wrapper. OK. That seems like finished. And this is your wrapper. If you extend it, you see the design here. So double clicking the design should bring the design back. You can generate layout. Okay, you can modify it. So now we need to program the hardware. In order to do that, there are basically three steps that the Vivado uses: the synthesis, the implementation, and then generating the Bitstream, and then running the programming of the FPGA. If you hit the generate Bitstream, Vivado will go through all the steps at once and to generating the Bitstream. So let's do it. Some message here, yes. Another message, yes. Now this waiting indicator is just to confuse you a bit. When it disappears, it is not finished yet. The function is not finished yet. Here on the bottom you have the TCL console where you see what the Vivado is doing. Now once this first waiting indicator is finished, you see this progress little indicator on the upper right corner of Vivado, and you see that it is rolling, which means Vivado is working on the synthesis implementation and creating the Bitstream. So that will take quite a while. It may take 20 minutes on a fast machine, hours on a laptop. So this is time for you to take a coffee, eat some sushi, take a trip to Mars, and come back to see the results. So we have the Vivado finished the compilation of the hardware, the synthesis implementation, and generating the bitstream. Here later on you can investigate the implementation design. It is important when you have a bigger design and you need to see that the hardware design fits into the size of the FPGA. As for now, we just go cancel. Now, what we need to do is go to File, Export, Export Hardware. We will need it for our software program. Here is an important thing to include the bitstream. And this by default always comes off as off, and this should be on. Include bitstream and OK. Now we can program the hardware fabric into the FPGA. So on the left side, on the bottom, open Hardware Manager. We have the board connected already. Open Target, Auto Connect. Program device, refresh device. It says programmed. Anyway, I right-click this and I hit program device. And program. Seems like finished. On the upper right, we see a check mark. Yeah, that seems like finished. Now we will go to do the software. And to do this in Vivado 2019, the configuration is a little bit different. Before, in the previous version, 2018, we had File, Launch, SDK. Right now, we have Tools, Launch Vitis. And the Vitis is the same thing as SDK, just different name and maybe some other differences. Launching. Yeah, looks like we're launching. So we have the screen of Vitis, and I use this Xilinx code /v219 2019 /Vitis for the workspace launch. Here we have the screen. I'll go through the step again to create the project. Anyway, we have the Vitis running and we also have the Vivado running separately. You can close the hardware manager in Vivado, go back to the block design diagram, and we will be checking the components here to program the software. So over here you will have several steps. The hardware part of the project is already created, but we can basically recreate it. So over here you would have empty space in the Explorer tab. So let's delete those. Just Notepad to copy the software that I have done before. We delete this too, just so we can see the clean start for the project. So we go File, New, Platform Project. And the project name, let's call it Platform 1, let's say. Next. Okay, XSA file. This is the hardware file that we generated by exporting the hardware from Vivado. So browse for it. This was the project, the design one wrapper XSA. That should be it. Microblaze 0. Standalone. Finish. That should bring the hardware description from Vivado into the software project. This XSA extension has changed since the previous Vivado version. All right, now we go to File again, New, Application Project, and let's call it same as the design, y_CModA7 app. One, let's say. Okay, next. So this will give us the choices. We select the platform 1 that we just created recently from the XSA file, CModA7 that should be fine. Yeah, that looks good. Hello world. Finish. Okay, so this is our hardware definition. This is our project. Now we go to source and we hello world. I basically copy this, remove it, and copy into it the code that I have written before. Let's verify the code a bit. So we have GPIO initialize. This is the xgpio 0 that should be for the output for the LEDs and output for the RGB LEDs, and we have GPIO 1 for the input of the button. So here it is. If we check it in Vivado, we have GPIO 0, and it is connected to our LEDs and RGB LEDs. And we have GPIO 1, which is connected to the button. Okay, that should be fine. So here is our code to grab the input from the USB, and we have several functions that we define here. Let's say we want to change the LED value, what's displayed. We have a function for this that we will be sending from the computer, RGB. All right, so on the left in the Explorer, right click on the project and do build project. Now in the SDK or the Vitis you wish, the progress indicator is on the right bottom. So here it is. It's rolling. This takes reasonably faster than building the hardware. Seems like finished. Now we go to, so this is the console, we go to problems to see if anything is here. I don't see any problems here. We should be able to run our program on the hardware, on the microcontroller that we programmed into the FPGA. So I click the run button. And there are no recent launches. Okay, let's see what we have here. So run as project debug. Let's try it. Allow access, I guess. Okay, it is programmed in our software. I can show you that we have a little bit of a state machine here. So state 0, it should blink our LEDs. So let me see how it works. So the LEDs are blinking. Okay. We go to our control program on the PC. Our COM port is COM15. We go to 115.200, open. The port is opened. I send the command of version. Okay, we got the correct version that we programmed. And let's say we change the mode, run equals 0. The LEDs are blinking. Run equals 1. The LEDs are stopped. Okay, let me program the LED. LED equals 0. They disappear. RGB equals 7. That turns them all off. RGB equals 0. That turns them all on. 7 again. All right. LED equals 1, let's say, for trial. On, I guess. And back to the default state of blinking. And we're blinking again. Okay, that pretty much concludes the main part of this tutorial. A quick note about how long it takes. So creating the Microblaze design, it took about 20 minutes. Then waiting for the Vivado to finish building the Bitstream and programming the hardware took about 15 minutes on this particular laptop. Creating the software project approximately 10 minutes. So we were done within 45 minutes. Thank you very much. Enjoy. Thank you.